Good afternoon and welcome once again to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And today we will be introducing ourselves to topic number 6, differentiation of pure mathematics 3. And we know the basic rules of differentiations, and of course that is exactly what you're supposed to use. For example, we know the first principle. And the first principle of anything, we know that when we have y is equals to fx, or rather let fx be equals to, or rather y is equals to fx, and we know that if y is equals to fx to start with, the f prime x is given by the function of some x with some limits, of course, minus the function of x, and this one happens when we have limits of h approaching 0, everything over h. And I want to remind ourselves something in a general differentiation. For example, if y is equals to x squared, then dy dx is going to be, and we have a graph that looks like this, and that probably is point A and this is point B. The coordinates of this point A is x, y, which is x squared. And if you take some distance from this point A to B, there is a h. If this horizontal distance is h, then the coordinates of point B is x plus h squared. And well, if we want to get now the gradient, the dy dx of this is y2 minus y1, which is x plus h squared, minus y1, which is x squared, everything over x plus h minus, this is x2 minus x1. This one ultimately gives us x plus h squared minus x squared all over h. And that is why we say if we have a function of fx, then the derivative becomes the function of x plus h, whatever the function of x was, minus the function of x all over h. So in this case, this is just a reminder. This is called the first principle. This is called the first principle approach. The first principles, that is the first principle. I would also want everybody to note that to differentiate sine x and cosine of x from first principle, we can use the following small angle approximation for sine and cosine when the angle is measured in radians. And these are some standards information that the sine of x approaches x, and the cosine of x approaches 1 minus a half x squared. These are some fundamental information that we need to have in mind even as we maneuver the differential of trigonometric ratios. And of course, let's talk of the function of x, for instance, being equals to the sine of x, and the derivative of this from the first principle is going to be the function of x plus h minus the function of x, everything over h. And the function of x was sine x. That means this is, of course, as h approaches 0, as h limits to 0. And this one becomes, we have a limit of, as h approaches 0, we're going to have the function of x was sine x. So we are going to have the sine of x plus h minus the sine of x, everything over h. But according to something else we've understood in the same kind of reasoning in a previous video, that in trigonometric addition angle formulae, we know that the sine of x plus h is given by, of course, we continue to talk about as h approaches 0, the sine of x cosine of h plus the cos of x sine of h, that is simply that part, and everything minus the sine of x and of course over h. That means still with the limit as h approaches 0, we have the sine of x, and this is obviously now the derivative of x, the sine of x cosine of h minus the sine of x. We just brought this negative sine x to this side because we are likely to have the like terms there, plus the cosine of x and the sine of h, everything over h. And sure enough, we have to have sine x outside. We have to have sine x outside, and inside the bracket we have let's have the sine of x outside. We are talking about the cosine of h minus 1 plus the cosine of x plus the cosine of x sine h. Of course, now everything is over h, and what do we have? We have something. We have over h and over h. So we have some constants that do not have anything to do with h, and therefore we can they are not affected by as h approaches 0. So the sine of x is one of them. It's not affected by h, and therefore we talk about still within our limit as h approaches 0. We have first of all, let us have the sine x outside and concentrate as h approaches 0. We have the cosine of h minus 1 all over h plus the cosine of x is again not affected by the h, so the cosine of x into before we go into, of course, we have the limit of as h approaches 0, now into the sine of h over h. Having reached there, of course, we have to talk of we have to talk about these limits, and I would want us to talk about as h approaches 0. We know that the cosine graph is simply something like this. This is the cosine graph. As x approaches 0, the cosine is simply 1. So the cosine of 0 is 1 as h approaches 0. So we are going to have 1 minus 1, which is 0, and 0 divided by anything is simply 0. So we are saying that within our limit as h approaches 0, we are going to have the sine x multiplied by 0 plus as h approaches 0 over 0, this one becomes 1. But I want to explain this in a different forum. Let me say this. Let me just explain what happens here. If I have a unit circle like this, and that is the center of the circle, and that is the radius 1 unit, and that is something to do with let me talk of h. let me talk of h, angle in between, or the angle subtended at the center. Of course, there is a 90-degree there. And if this is 1, the radius is 1, so the sine of this small angle is going to be opposite of a hypotenuse. So the sine of h is equals to x over 1. If we put it over here, we're going to say the sine of h is equals to, let's call it p, this opposite direction. This is p over 1. So in other words, the sine of h is simply p. So what is p? This side is the sine of h. That side, the opposite side, is the sine of h. At that particular point, as you can see, if we want to talk about L with radian measure, the length of this arc, the length of that arc, definitely the way we know it, L is equals to r theta. And in this case, r is 1. So L is equals to theta. And you can see, as h becomes very small, this radius, or this perpendicular height, as h becomes very small, this perpendicular height, which is p, will almost be equaling the arc. So as h approaches 0, I mean the sine of h will be approaching theta. It will be approaching L, which is theta. So when the sine of h will exactly be equals to theta, if you divide by theta and by theta on both sides, you'll find that the sine of the sine of h over h, because we are talking about the angle in between, will be h over h. This is the angle we are dealing with here is h throughout. So the sine of h over h will be h over h, which will be 1. So that explains why the sine of h over h is 1. 1 times the cosine of x. And therefore, this tells us that sine x times 0 is 0, plus 1 times cos x is simply cos x. So therefore, this is the cosine of x. And what conclusion do we have? When fx is equals to sine x, then f prime x is equals to the cosine of x. And that has been proven there. And that is exactly what we want to show in the first example, which was example number 1, and we have finalized there. So follow, it may not be very clear, and especially this part, I think I will do it in a different video. I think the video that follows here, the video that follows this one, will be explaining this part. So don't worry, let us see to it that we visit my YouTube channel, Pearson and Excel Math by Mr. Kamotho. Subscribe and share widely, and let's move on together.